Hi everybody. We're gonna continue the rest of the content on file input and output. We are here at Thursday, week 9. A couple days ago on Tuesday, we finished the lesson 13 and we got partway through the lab 13. This was about file input and output. So let's go ahead and complete the rest of this lab together. And then after that, we'll go on to some hints for this programming project. This programming project is called Mad Libs. This is like a game that some people might have played a while ago. All right, so let me open up my lab. Once again, we did finish lesson 13 a couple days ago, right here. We finished everything. The biggest takeaways from this lesson are pretty much reading text files and writing. All right, so that's really it. If anything, there are some extra stuff down here, extra file types. We went over how to open up image files, some audio files, and then we talked about spreadsheets. You don't have to know about this too much yet. In a few more weeks, this will be important. We're going to talk about data science towards the end of this course. And data science will involve loading data in to some sort of table. So we'll talk about that later. If anything, yeah, we just need to know how to read and write files. Okay, so let me go ahead and open up the lab and see where we left off at. Lab 13, here we are. Okay, cool. Let me rerun these cells. So there we go, rerun. Okay, we did this one here. Where do we leave off? Okay, we left off at number 3. So I'm hoping folks gave this a shot. If you didn't give it a shot, please go ahead and maybe pause the video and try it out yourself. This way you can maybe run into possible errors and start troubleshooting it. Okay, so number 3 right here, this is asking us to write some code that dumps text into a file. In particular, we're going to be dumping it into a file called fish.txt. This doesn't exist in our current working directory yet, so let's go ahead and make it exist. Okay, so you might remember from a couple days ago, right, we can open files. In this case, I'm going to open a file called fish.txt, and then I'm going to open it in a write mode. Right, write mode, meaning that the file handle will have access to write data into it. Okay, you might also remember that if this file doesn't exist, it's going to be created, right? Because we opened it in write-only mode. Okay, so let's go ahead and test it. So this does return a pointer. I'm going to store it into a variable called file handle. And very, very important, make sure you close it. Right, always close, otherwise you'll have memory leaks. Okay, and then in between, we just have to use the file handle to dump contents into the file. All right, so you can look at the previous lesson for this. This previous lesson, scroll down to the writing text files. All right, all we really talked about was this function called write, where you can pretty much put some argument in here and it'll dump that data into the file. So let's go ahead and use this. So we need to use the file handle .write, right, and we need to dump some data here, right? In particular, these are just strings. So I'm going to dump this first line into here, right? One fish, comma. Okay, it's a good idea to test it frequently, so I'm going to actually test it right now. Okay, so I'm going to run this cell. There it is. I just ran it, and we should see a brand new text file here in the current working directory. Let's see. I might have to refresh it. So once again, you can refresh by clicking here. Okay, so refresh, and then let me see if it existed. Here it is. Fish.txt. There it is. Let's sanity check it. So I'm going to open it in split screen. There it is. There is the file called fish.txt, and it contains one line. Okay, let's carry on because we sanity checking. We need to get the rest of these lines. So let's go ahead and write more. Right, the next line we need to write is to fish. So whoops, to fish, comma. Okay, let's see what's gonna happen. So just a quick warning. Opening a file in write mode does clear the contents. This is kind of dangerous because if you open the wrong file, you can possibly delete everything from it. So be careful. In this case, it's okay to clear it because we're going to be writing the same data into it. Okay, let's go ahead and test this. So I'll press play here, and let's take a look at the fish.txt now. So I'm going to reload this file here to see what it looks like now. There it is. Cool. So we see that the text file now has one fish, two fish. However, we should probably put them on separate lines. And the write function doesn't really work like a print statement. Right? Print statements immediately puts a new line for us, right? Meaning that when you print something, it's going to go to the next line for us. But with the write functions, there's no new line provided, so you have to do it yourself. So I'm going to put a \n here, which means new line, right? It's like an enter key. Okay, and then I'm going to put it here as well. And let's go ahead and run it again. So I'm going to quit this text file on the bottom just so I can reload it. So press play here. Okay, there it is. I press play, and let's check the fish.txt. Okay, sweet. It looks like the new lines put them on separate lines now. Okay, cool. Now we can carry on to writing the rest of this. Okay, so red fish, and then finally blue fish. Okay, let's test it. So press play, and then let's look at the file. And yeah, looks good. Cool. We successfully wrote a 4 lines into a file. Let me ask for feedback here. So all tests passed. Okay, great. All right, let's carry on. So these next questions are asking us to read from that file we just created. Okay, this first one is kind of like the opposite, right? It's saying, hey, now read the 4 lines. All right, so we're no longer going to be writing data into here, meaning we're going to open up the file in read mode. All right, we're opening in read mode, so the file handle will have access to grabbing data. So you don't have to put this R here. Once again, it uses a read mode by default, so you don't have to specify it. Okay. Cool, so let's go ahead and store this in a file handle so we could do operations on it. Like a close. All right, this is close it, and in between we do have to read 4 lines. All right, there's so many different ways to do this. I'm gonna do the naive solution and just read lines over and over again. So you can just kind of repeat this read line function. Right? If you scroll up a bit, you might remember that you can just read line. This is going to return a string, and we can store it. Okay, cool. So let's do that. So file handle dot read line. Once again, this is a function that returns a string, and it's going to seek onto the next one. So I'm going to store this string into something called like line 1. All right, you can call it whatever you want. Okay, so that's grabbing the first line, and let's grab the other lines. Line 2. Okay. There we are. So we read 4 lines, and we stored them into 4 different string variables. Okay, cool. Let's go ahead and print them. So you could print it before closing the file handle, but I'm gonna close it. I'm gonna print it after the closing, right? Because we already stored the data into these strings. So all we have to do is print it out, right? So let's go ahead and print. It does say print it in reverse order, So I'll go ahead and print the line 4 out first, and then the other ones. Line 3, print line 2, print line 1. All right, let's test it. So press play, and there we go. We see that it prints the poem that we just wrote, right? It's reading all of these 4 lines, and then just dumping them out in reverse order. Okay, cool. There are some extra new lines here. And the reason why is because this print statement inserts a new line for us. So you can't really see it, but when we read these lines here, they have a new line at the end of it. So you can imagine this file. There's kind of like an invisible new line character at each of these, right? So you don't see it, but it is there, meaning that when we print it, there's a duplicate line, right? A duplicate new line. So if you wanted to tell print to not print new lines, then you can use an optional argument, right? I think the optional argument is you say something like end is equal to nothing. Right, so let me paste these in. This is telling the print function to not use an end line. Okay, so let's test it. And there we go, right? It doesn't insert a new line. If you're kind of still confused on, whoops. Let me see, should I save this? Yeah, I'll save it. No, I won't. If you're confused on what this extra argument is, let me just do another example real quick. So remember we did something like print hello world, and then print how are you or something. Right, how are you? So in this case, it's going to print 2 separate lines. Right? The print statement puts a new line at the end of this for us. Right? So we don't have to do the new line here. I mean, if we did, then it would put another new line. Right? But if we told the print statement to say, hey, use nothing for the end, right? This is going to omit the new line. Right? Hopefully people see what's happening now. Right? So that's kind of why I put these optional argument in here. And if you're curious how I knew about this, you can look at the primary documentation for the print statement. So you can look up like Python functions, and then here's the built-in functions for Python, primary documentation. And let me take a look at the print statement. Here it is, print. So let me take a look. And it is a little hard to read, but the point is this documentation is telling us that the print function defaults to putting an end line for each of them. So we kind of overwrote the argument and said, hey, make it print nothing for the end. Okay, let's move on. So there we go. Okay, next one is really the same thing, but a different style. It's saying, hey, now read from the same exact file, but store each line into a list. So you can look at the previous lesson for this. There's a nice shortcut, actually. So going to the lesson, there was a nice shortcut on reading lines into a list. All you have to do is convert the file handle into a list. Right? And then, yeah, that's really all you have to do. And this is going to store each line into a separate element. So let's go ahead and use that. Okay, so first we need to open up the fish.txt. All right, open fish.txt. I'm going to open in read-only mode. Store it in a variable called file handle, and then close it. Because in between, we're planning on converting this file handle into a list. Right? This is a very nice Python shortcut, by the way. Right? All you have to do is say, hey, list, and then file handle. And there's going to be a lot of magic happening in the background. Right? Basically, the magic is it's going to read the lines over and over again for us. So I want to store this into some list variable. All right, I'll just call it lines. Okay, cool. So there it is. Let's go ahead and test it. So I'll press play. It doesn't print anything, which makes sense because we never really outputted anything. If you wanted to print out the lines right here, you could. So let's print out the lines to verify. There it is. Here is a list that contains 4 elements. Each element is a line in the file. Okay, people cool with this so far? Okay, great. Moving on to the next one. This one is asking us to use the list that we just created. So let's go ahead and use that list and print that last line. Okay, there are 4 elements in here, right? And we start indexing from 0. So 0, 1, 2, and 3. The last line is represented by the index 3. So we can go ahead and print that. All right, so we'll get the lines, right? The list is called lines, and we can access the last element, 3. Right, and then say something like print it. All right, this is going to print out the very last line, blue fish. All right, people cool with this so far? Okay, all tests pass. Great. I do want to point out something that there's a lot of ways on getting the last line in a list, by the way. This 3 is technically hard-coded, meaning that if we had a larger file, it's not guaranteed that 3 represents the last item in the list. So, you could you could generalize this 3 into the length minus 1, right? Because this number comes from the length of the list minus 1. So you could say length of the list minus 1, right? In this case, it's going to evaluate to 3. See, it prints the same exact thing. Unfortunately, this feedback cell isn't really that smart. See, I just ran the feedback cell. It's kind of forcing us to not be as creative. So I do want to point out that it's okay to be creative in this class. You can do so many different ways. It's just that the feedback cell isn't programmed robust enough, right? This feedback is really looking for the number 3. So don't worry about it too much. I'm not really focused on the feedback cell too much. Okay, anyways, there's a lot of ways, right? You can say the length minus 1. In Python, you can actually do some pretty cool stuff. You could say -1. In Python, this represents the last element in the list. So you could do that as well. Okay, great. Let's move on to the part 2. All right, part 2 is a little harder. It's going to be asking us to write functions that perform file input and output. This first one is asking us to write a function that pretty much wraps the read function. Right? It's saying, hey, write a function that takes a file name as an argument and then pretty much returns us all of the data in that file name. For example, I'm not even going to code this yet. I'm going to pretend that the function does exist. All right, let's pretend it does exist, and it'll kind of make a little more sense on the purpose. Okay, let's see. Can I type here? Can't type in this cell. Okay, I think I pressed the keyboard shortcut on accident, which made this read only. Let me modify this cell. Go here. Editable. Okay, cool. I can type in the cell now. Okay, so let's pretend the function does exist, and we're going to use some file called example.txt. So imagine if we had a function called read file, and then we gave it the location for this example. Right? Unfortunately, we don't have this example.txt in our labs folder. Right? So you're looking at the Explorer on the left. There's none. This file resides in the lessons directory. meaning that we'd have to go backwards, go into lessons, and then files, right? And that's where the examples is. So you could represent the file name as the path to it, right? So that the path to it is relative to this labs directory, right? It's relative because that's what we're working on right now. So we would have to represent this relative. So you say go backwards, right? / / means go backwards, and then go into lessons, and then files, and then example.txt. Example. All right, this is saying, once again, it's going backwards, going into lessons, files, and then it's grabbing examples. So you can imagine that this function is going to, open up this examples file, and then should return us something. Right? In this case, we're expecting this function to return all of the data in that file as a string. Okay, meaning that this function does evaluate to some value, and we could store it. We could store into some variable. Hold up. I don't know what keyboard shortcut I keep pressing, but I can't type in here. Okay, there it is, editable. Now I can type. So anyways, this function returns a string. We could store it into some variable. I'll call it like data. Right, data is going to be a string, and if we were to print the data, right, if we were to print the data, it should print all of the contents in this file. Right, so hopefully people see what the goal of this function is. Let's go ahead and code it. So for now, I'm actually going to set it up. This function is named read file. Right, so define a function called read file. It takes an argument. In this case, it's called file name. Okay. And real quick, I'm going to put in a dummy return statement just to make sure things are running fine. So I'm just going to return like testing for now, right, just to make sure we don't have any syntax errors. Okay, great. So return testing. Let me load the function into the kernel, and then let's test it. So I'll test it, press play, and yeah, it prints testing, right? Which makes sense because this function returns the string no matter what. Okay, let's go ahead and implement this function now. So let me get this doc string in here. The purpose of this function is to return data from a file. The parameter, the input here is file name. This is a string that represents the path to the file. All right, people cool with that. And then there is a output. It's going to return the contents of the file as a single string. So there's pretty much going to be a single large string that represents all of the data. All right, let's go ahead and start coding it. So this is a read file, right? Meaning that we have to take this file name and open it in read mode. So I'm going to open it. All right, there we go. Open it in read mode, and then this R for reading. Let me store it in a file handle, and then go ahead and close it right away. Cool. So in between, we need to read some data, right, and kind of store it in a string, because we're planning on returning that string later. So you might recall from the lesson that you can do a function called read. Right, there's two ways on reading. I mean, there's a lot of ways on reading. Well, we saw a couple, right? One is read line, and then another one is read. Right? You might remember that this read function will literally grab everything in the file. Right? It's going to go from top to bottom. So we could reuse this. Let's go ahead and say file handle.read. All right, once again, this does return a string, so I'm going to store it into a variable. I'll restore into something called like contents. All right, so contents will become whatever we read, and we can go ahead and return it. All right, let's go ahead and test it. So I'll press play, and then go ahead and run this. Great. There we are. All right, people cool with this? All right, so this is pretty much saying, hey, go into this file. Right, that the function is now going into this file and then reading all of these into a string. All right, people cool with this? And you can test this with multiple things, right? Like you could, let's see, let's test it with a different path. Like in our labs, we do have this fish.txt. So we could test it with that right there. Right, let me comment this out. We could say data is equal to read file, and then give it the relative path to fish.txt. Fish.txt is in the same working directory, so we only have to say fish.txt. Right? We don't have to navigate to it. Okay, so let's see. Let's play this. Let's play, and there we go. Right, it's now printing out the data in that file. Right, people cool with this stuff so far? Okay, great. Okay, let's move on. A few more. This one is the opposite, number 2, write a file. Right, in this case, it's going to take 2 arguments. The first one represents the name of the file to write, and then the next one represents the contents to dump into the file. So let's, first of all, I'm going to pretend that it does exist. Right, let's pretend, meaning that if I were to invoke this function, called write file, and give it the arguments, right? I'm going to give it like a file name. I'll name it output.txt, and then the next argument represents the data to put in it as some string. So let me go ahead and put like some random string here, like testing 1 2 3. Right, the goal of this function should be to create a file named output.txt and dump this string into it. Okay, and let's go ahead and define it. So define a function called write file. And let's get the file name and the contents. All right, I'll go ahead and declare the docstring. The purpose is to dump contents into a file. Not really dump, more like overwrite. Right, overwrite contents. Yeah, I'll just say write contents into a file. Yeah, write contents into a file. There are 2 parameters. You know what? I realize I've been using a docstring from a different language. My bad. I was using. I don't think people have seen this before. This syntax right here. I was accidentally using Java syntax. Java is a different language, but this is still fine. It's still fine. There's 2 parameters here. One is file name. This is the name of the file, and then next is contents. This is this is a string, right? The data to write into the file. And in this case, we are expecting it to return something. We're expecting it to return the number of characters written. So return the number of characters written. All right, once again, don't worry too much about the syntax of this. I accidentally did something called a Java doc. Right, this is, just looking it up, a Java doc. It's a different language, and it uses different formats. So that's pretty much what I was using here. Don't worry too much about it. This is just a comment. It's still a doc string. Okay, so let's go ahead and get this ready. This function is going to open file name in write mode. Okay, so we're in write mode, and this does return a file handle. And once again, be careful with this, right? We're opening it in write mode, meaning that it's going to clear the contents in this file. In this case, this file doesn't exist yet, so it's actually going to, create it for us. All right, let's go ahead and get this closed in right away. All right, close, and then in between, we gotta dump some contents into it. All right, we gotta dump this string. So you can literally go file handle dot write. You might remember this, and then give it some string, right? This contents, and yeah, that should be it. Let's test it. We're not done yet because we need to return the number of characters written. But let's test it. Let's make sure that it's able to create a file and dump the contents. All right, so I'll load the function into a kernel and then test it. So here we go. Press play. And then here on the left, Explorer, go ahead and refresh it. So I'm going to refresh it. There it is. I just refreshed it, and we see a brand new file here, right? See, it says output.txt. Let's verify the contents. Perfect, right? It's looking good. Okay, and let's keep testing it. Like if I were to, give a different value for the contents, like hello. Hello world, right? Just anything. Let's go ahead and rerun it. So I'll rerun this function. Press play, and then let's check the output now. Right? It should be different. All right, see, there it is. It no longer says the old stuff. It says hello world. All right, once again, the reason is because this function, when we open it in write mode, it clears out the whole contents in preparation to writing new data into it. Okay, hopefully that makes sense so far. So we're pretty much done. We just need to return the number of characters written. And you might remember from last week that this write function does tell us, right? It does return a value. We're just not capturing it. Right? It returns a value that represents the numbers of bytes written. So you could call it bytes written. Right? This is it's going to be a number. Right, so there's two things happening here. We're going to dump contents, and we're going to store the size into this variable. And we can go ahead and return it. There we go. So we return bytes written, and then let's go ahead and play this now. This should do two things now, right? It should dump this contents and give us a value. So let me press play. The value here is 11. Right, but yeah, once again, there are two things happening. Right, it overwrote this file, and then the function evaluated to some number, right, 11, because that's how many bytes we wrote into here, how many characters. Okay, people cool with this so far? Okay, cool. This is a return value, so you could capture it if you wanted. Let's see. I can't type in here. I need to look this up, but I keep pressing some keyboard shortcut that disables the cell. Okay, let's see. This does return a value. You could store it into like some variable called size, or you can call it whatever you want, and you can print something like successfully wrote this many characters. Make this an F string. So there it is, right? Successfully wrote 11 characters. Right, this size is useful because it'll tell you, it's like a loading bar, right? From last class, it kind of, you can use this number and tell whether or not the data dump was successful. Okay. All tests pass. Great. Okay, let's move on to some more. A couple more. This one, summing values. This is kind of a useful one. This is probably one of our first data analysis problems. You can think of it as This function is asking us to sum up numbers in a file. So you can imagine that there's some file with numbers on every line. It might be useful to kind of add them up. So let me go ahead and create a file that contains numbers. Here's a block of code that will create it for us. Right? It's going to say, hey, create a file named numbers, and we're going to dump 4 floats into here, right? 4 floating point numbers. So let's go ahead and write this first. Okay, so boom, play, and then let me refresh this on the left. Great. So we're going to be working with this file here, right? You can work with whatever file you want, but here it is, right? This is a brand new file that we just made. Imagine if we were to write some function that takes in a file of numbers and returns us the sum, right? The sum here is 1 plus 2 plus 3 plus 4, so it should return 10. Okay, this means that if we were to test the function, which is called a file sum up here, right? Scroll up a bit. Imagine if we said file sum and then gave it the argument, the path, which is numbers.txt. Right? This function should return the sum of all of those numbers. So I could put it in here, call it like total is equal to this, and then print out the total. And it should print out 10, right? Because that's the sum of all of the numbers in here. Okay, cool. So that's just kind of, imagine if we had it. So let's go ahead and define the function. This function is kind of making some assumptions. It's saying that you only need to read the first 4 lines. So let's go ahead and write that. Let's define a function called file sum. Okay, it takes a string as a file name. The purpose here, the purpose is to calculate the sum of numbers from a file. Here there's a parameter, right? There's one argument. This argument is a file name, which is a string that represents the path to the file. Okay, and then there is a return statement here. It is going to return the sum. Okay, great. Let's first of all, it's a good idea to test frequently. So I'm actually going to return 0 temporarily and make sure we don't have any syntax errors. So I'll press play here. Cool. Yeah, this runs. Let's go ahead and run this over here. This is the testing cell. So I'll press play, and yeah, it prints 0, right? Which makes sense because we hard-coded the function to return 0. If anything, it should print 10 because that's all of the sum of all of these numbers. All right, so let's go ahead and do that. All right. Okay. Okay, great. We do need to open up this file, right? Because we are planning on reading the numbers into it. So let me go ahead and open it in read mode. Okay, and go ahead and I'll close it right away. In between, we're planning on reading 4 lines, right? In this case, just 4. Okay, so you might remember that we can do like a read line. So file handle.read line. This does return a string, so we could store it into like maybe line 1. All right, and we just got to do this 3 more times. All right, line 1, line 2, 3, and then 4. Cool. So these are strings, right? Line 1, line 2. We just have to add them up now. We got to return the sum. So maybe maybe you might be thinking of summing them up and storing them into a result, right? So let's see what happens. Let's see what happens if we created a result and kind of just added them up. And then we do need to return it, right? So return the result. So people see what's about to happen here. Let me kind of predict. Let's try to trace what's going to happen. So we're telling the function to use this numbers.txt. Right, so we're going to go into here. File name becomes numbers.txt. We're going to open it and then read 4 lines and store them into some string variables. Right, so this line 1 becomes 1.0, line 2 becomes 2.0, and then so on. So hopefully we end up with the result, right? Because 1 plus 2 plus 3 plus 4 should give us 10. All right, but let's see what's going to happen. So I'll press play here, and then go ahead and test the function. All right, so let's test it. So press play. Okay, there we go. Right, it didn't give us 10. Right, for some reason, it printed out the numbers verbatim, the same numbers that we have. Right, isn't that weird? Yeah, it's kind of weird, right? If you're curious what's happening, we're doing something called string concatenation. These lines are strings, meaning when we add them, we're not really doing mathematical addition. We're kind of gluing strings together. So what we're really doing is this right here. Right? Let me go to a new notebook, just so folks see what I mean. What we're actually doing is adding strings. Right? We're doing 1.0, a new line, because that's what these strings become. Right? The second line becomes 2.0 /n, and then 3.0 plus 4.0 and new line. And we store this into a result. Right? So this is what we're doing here. We're saying result is equal to the sum of these 4 strings. So we're getting this, and when we print the result, right, we get literally the numbers glued to each other. So it might be useful to convert all of these strings into floats. Right? Floats are variables that represent decimals. So one way we could do this is by using this conversion notation. Right? We're saying, hey, convert this string into a float. So I'm going to do that to all of them. Okay, cool. So yeah, now these strings will be converted to actual numbers where we can actually sum them up now. And there we go, right? It gives us 10. Okay, so let's go ahead and apply that to here, right? We got to convert each of these to floats. There's a few different ways you can do that. You can do the same thing, right? Wrap all of these strings in floats. You could actually do it here as well, right? You could say, you could convert it straight away from here. But I'm actually going to do it down here. There we go. So we converted it. Let's go ahead and test it. So I'll press play here. And then let's go ahead and test it down here. We don't really need to run this cell again, by the way. It's because we already have the numbers file. All right, let's go ahead and test it. So press play, and it should print 10. There we go. All right, prints 10. So it's successfully summarizing all of these. Not summarizing, accumulating them. Okay. Let's keep testing to make sure we're fine, right? Like if I were to change some numbers in here, like maybe let's use 4 different numbers, like maybe 1.3, 4.5, 0.0, 0.1. I just chose 4 random numbers. And there it is. I just saved the text file. Meaning if I were to rerun this cell, it should give us the sum of all of these, which is 5.9. Right? Right? Adding all of these should give us 5.9. So let's test it. Press play, and there we go, right? 5.9. You don't have to worry about these this imprecision here, right? It should say 5.9. It's saying 5.8999. If you're curious why it's floats are hard to represent accurately in computer science. You could dive into this if you want. You could look into how floats are represented. Float representation on computers. Computers have a hard time representing floating numbers. Now, the reason is because floats have a lot of precision, and in computers they use binary. And binary can't really represent perfect precision with decimals. So you could look into this stuff if you want. The Wikipedia here. You'll learn this in another class called CIS-15, but I'm not going to cover it here. Okay, hopefully that makes sense then. So yeah, this is 5.9 pretty much. I'm going to go ahead and round it. I'm going to go ahead and round the total to 2 decimal places. So let me round it to 2 decimal places. There we go. And 5.9. Okay, great. All right. Hopefully that people are cool with this. Any questions about summing values? Okay, cool. Let's do one more and then we're done with the lab. This last one is a little tricky. It's asking us to combine reading and writing. In particular, it's asking us to write a function that rearranges text in a file. Imagine if we had a text file that has these 5 lines. The goal of this function is to rearrange these lines, meaning that we're going to put the first line to the bottom. All right, so this is before and this is after. Okay, I am going to create a file that has this text over here. So let me copy it, and maybe I'll put it in a file called. Let's see. I'll just put it into test.txt. Right, this is over here, test.txt. We had this from the very beginning of the lab. I'm just going to go ahead and overwrite it. Cool, so there's our text file. Let me save it, Control S. There it is. Okay, so let's talk about the goal of this function here. The function is called top to bottom. So imagine if we called the function, invoked it, I mean. Imagine if we invoke the function, it's called top to bottom. And then it takes an argument, which is the path of the file. So in this case, I'm going to say tests.txt. Okay, that's it. This is how you invoke the function, because we're not really expecting it to return anything. But the expected behavior of this function is it should open up this text file here, right? It should open it up and rearrange some lines, right? It should put line 1 all the way to the very bottom. So how do we do that? Right? Isn't it like with what we know so far, we would have to do reading and then writing. You can imagine a function that opens up this file in read mode, right? And then it stores the first line into some string, and then it will grab the rest of the lines, store into another string, right? And then we could go ahead and open the file again in write mode and dump the contents into it in kind of like reverse order. All right, so basically we're going to write the function that does 2 things. Right? It's going to read the data into some variables, and then we're going to open the file again to dump the contents back into it. Cool, so let's go ahead and write this function. Right? The function is called top to bottom. Okay, it only takes 1 argument, file name. All right. Let's get this doc string ready. Places the first line to the bottom. Places the first line to the bottom of a file. Or moves the first line in a file to the bottom of that same file. Okay, and there is only one argument. It's the string represents the path to the file. And then finally there is a return. Wait, no, there is no return. We're not expecting this function to give anything back to the caller, right? This function just needs to do something. It doesn't need to evaluate to some number or some string. Okay, so yeah, first step, right? We do need the function to open the file, right? Because we need to grab data from it, since we're planning on rearranging the data. All right, so let's go ahead and open up the file. So I'll open up the file in read mode. Okay, file handle, and then it's good programming to close it right away. Okay, cool. Now we just need to read the data into some strings, because we're planning on rearranging those strings. All right, so we do need this first line. All right, so let's go ahead and read that first line. Okay, so this first line, filehandle.read line, this does return a string, so we should probably store it in some variable. I'll call it line 1. Okay, now we just need to grab the rest of this data here, right? We could store this into another string. So you might remember that we can combine this read line with the read function, right? Like here, looking back at the lesson. Looking back at the lesson, we talked about these two functions, and you can combine them, right? Because the file handle.read line, it'll read a line and then go to the next line. And if you were to do a read function, it's going to grab the rest of it from where we ended off at. So we could use that function .read. So file handle.read. This is going to return another string. A good name for this variable is probably rest of file. Rest of file. All right, so there we go. Let's talk about what's going to happen. So the function is going to open this file. It's going to store two strings. Right? The first string is called line 1. It's going to store into here. And then we're going to grab the rest of the file and store it into this variable here. Right, so two strings. Let's go ahead and verify real quick. Right, let me do a sanity check and print out these variables to make sure we're fine. Right, so let me print. This is a sanity check. First line is line 1. Let me do an F string. And then I'm going to sanity check the rest of the file as well. Rest of file is. Right, I just want to make sure we're grabbing the right data. Okay, cool. Let's test. So press play, and if I press play here, it should print out perfect. Right, first line is line 1, and then the rest of the file is right here. Whoops. Right over here. All right, so yeah, that looks good. Now all we need to do is open up the file again and dump these contents into it in reverse order. Cool. So let me get rid of these print statements. Let's go ahead and open the file again, but in a different mode. So file handle is equal to open. in write mode, right? Because we're planning on overwriting the contents and replacing it with brand new stuff. Okay, let me close it again. File handle.close. And in between, we just gotta dump contents into it, right, in reverse order. So we gotta write the rest of the file into it first, right, because the rest of the file represents everything but line 1. And then we could put in the other stuff. File, the first line here. Right. Okay, let me clean this code up a bit. All right, so yeah, people see what's happening here. Let's go ahead and test it. Let's press play, and then let's press play here again. Okay, cool, I just pressed play. I do need to reload this file, and when I do reload it, hopefully we see this first line moved to the bottom. So let's reload this, and then reload the file. Cool. So it looks like it almost did it. Right, people kind of see what's happening here. Right, the line 1 is happening not on a separate line. Right, do people kind of see why? Right, once again, it's because this write function doesn't put a new line for us. Right, so the rest of the file came from here, and it didn't do a new line, so this next write function just put it right next to it. So I need to restart. Right, let me restore this file back to its original state so we could test it again. Okay, so I'm going to copy this over again, and then fix this file so we can test again. So fix, there it is, copied. Let me save it. So save, boom. Okay. So yeah, people kind of seeing what's happening, right? We need to put a new line at the end of here. So one way you could do that is by just concatenating. Right? Concatenating means to add strings together. And in this case, I'm just gonna put the new line at the end of this string here. Okay, let's test it now. So press play and press play here. And let me reload the file. There we go, right? We see that the first line got moved to the bottom. Pretty cool, right? There's quite a lot of stuff happening here. But we're just, if you want to summarize what's happening here, this is reading data into strings, and then this is the opposite, right? We are dumping the data back into the file, right? We're just doing it in reverse order, right? Okay. We could run this function again, by the way, right? We could run this function again, and it's going to put this other line at the bottom. So, you can keep testing it, right? Press play there, and then we see that it got moved to the bottom. Oh, there's an extra new line here. So I guess there's we broke something by adding this new line. Okay. So yeah, this is a little tricky to see what's going on. Why is there an extra new line? Oh. Let's see. I think it's because when we hold on. Let me study this real quick. I'm going to restore it back to the original state. Let me see what's happening here. So the original state was right here. Let me see what's going to happen. So press save it. Okay. Let's see. And then let me run this here. So press play. Okay. And what did that do? Okay, that did the right thing, but then there's an extra new line at the bottom here. Got it. So this is a little tricky to see, but this line 1 came from over here, right? We wrote the line 1 at the bottom of the file. And you don't really see this, but there is a new line at the end of it. Right? There's an invisible new line, meaning that it put a blank line here. The reason why there's an invisible new line in there is probably because this read line function at the top, it read the first line and then kept that new line character. So, a quick fix you could do to this is by kind of stripping the new line. You could do like a dot strip. This is a string function where on default it's going to remove, I think, new lines at the side. Let me verify. Let me look at the string library real quick. So string Python methods. Let me make sure. So string methods. Let me look at the dot strip. Okay, returns a copy of the string. Deleting. Okay. Let's see. Okay, so by default, this function removes white space. We need to override it and make it remove the new line. So you could do that by saying dot strip and then saying chars. I think you can say chars is equal to new line here. I'm not sure if this is going to work. Let me test it. I do need to restore this file back though. So let me restore the file. Copy, paste, and then save the file. Let's test it again. Okay, cool. Yeah, I didn't think that was going to work. I think I had the syntax wrong. Let's see. Maybe I don't specify the parameter name. Okay. Okay, let's test that. Okay, sweet. Cool, so we successfully stripped the new line, and you can tell because there's no blank line at the bottom here. Meaning that if we test it again, it should be fine. So test it again, and then reload the test. And there it is, right? We see it move to the bottom. And let's test it again. So I'll run one more time, reload, and there we go, right? We see how it's moving the top to the bottom. Cool, looks good. Okay, any questions about this stuff? All right. We just finished the lab. We could move on to giving hints on the homework now. All right, so let me quit all of this stuff. Quit. This next assignment is called Mad Libs. It contains multiple files. So I suggest making a dedicated directory to this assignment. Right over here. Mad Libs with files. There are 4 files. There's 1 notebook and 3 text files. So make sure you download all of these and then upload it to a dedicated directory. So download, and then let me go to my projects. This is week 9, right? Week 9 Mad Libs. And then let me get those files into here. So there's the 3 text files and then the notebook over here. Okay. Let's see. Let's take a look at the notebook first. Okay, there's our notebook. Oh, okay. It looks like this notebook has some... Oh, you might want to clear it first, because it looks like I ran some cells, and there's some numbers here that might make you think you already ran it. So if you don't mind clearing the kernel, so go to the top here, and then saying restart kernel and clear outputs, because there's some leftover data from when I uploaded it. Okay, cool. Now I got rid of all the numbers. Okay, great, looks good. Cool, let me run this first cell. Before I jump into what this project is, let me talk about what Mad Libs is. This is a game that you might have played in elementary school. It's a game where originally it was a book. This book had a bunch of stories in there, and the stories are templates. And you could generate a funny story by asking a person, like, hey, what is a noun? Or give me an adverb, give me a verb, give me an adjective, and then those words will be placed into the story, and the story would end up kind of not making sense, but that's how Mad Libs works. Let me play a sample game. Is there an online tool? Let's see. Yeah, here's an online tool right here. It looks like someone kind of made this game. So here, let me play one real quick. Let me choose a small one. Is this small? Yeah, this is okay. So check this out. We need to fill in the blanks, and then these blanks will get placed into the story. The first blank is saying, name a place. All right, so I'm gonna say Santa Cruz. Okay, and then verb, right? What's a verb? Let's see. What's a good verb I could put in here? I'll just put program. Program is also a noun, but it's also a verb, right? Like, I'm going to program this thing. Okay, adjective. What's an adjective? Something. It's the word that describes something. Let's just say big. Okay, let's see another verb. What's another verb? Run. All right, run is a verb. Conjunction. I actually don't know what a conjunction is. Let me look up what this is. Conjunction. Let's see. This is a part of speech. Let's see what it is. Conjunction. Okay, so it says the conjunction is a joiner for words. Oh, so it's like saying and or but. Let me verify. What are some conjunctions? Yeah. Here's some examples. And, but, all right, just words that combine phrases. Okay, cool. So conjunction, I would just use and. Place, let's go Watsonville. I don't know, let's go Aptos. Another conjunction, I'll say but. Right, it's a word that combines two phrases. Adverb. Let's see. Quickly. Right, it's an adverb is like an adjective and a verb put together. Okay, let's see. Another conjunction. I'll just reuse and then another adjective. Let's say small. Okay, cool. So we filled in the blanks, and then now we can generate a story. So let me press this generate button. Go mad. And here it is, right? Here's a story. It's a story where the words we typed in filled in the blank. All right, so let's see. Let me just skim this real quick, see if it makes sense. Once upon a time, something, worked in a big Santa Cruz. Interesting. He woke up early to program. Was big. And he never gave up. Yeah, this story kind of makes sense, actually. As long as we got the parts of speech right. Okay, so people kind of sensing what this project is. Right, the project is we're going to recreate this Mad Libs. Right. So let's go to the notebook. Okay. This project consists of 4 files, a notebook, and then 3 text files. These 3 text files contain a Mad Libs template, meaning a story. For example, in number 1, let me open this in split screen. All right, madlib.txt, this is a file. The first line is a story. Right? It's a story template where the blanks are these curly braces. These curly braces will be replaced with whatever the user wants. All right, so this is a story. Okay, and then don't worry too much about these stuff right here. This is the parts of speech that's going to be included in a widget. I'm not expecting folks to code a widget, so I'm actually going to help folks out with that in just a bit. But the main point is the first line contains a story template. Let me look at more like this Mad Libs 2. All right, Mad Libs 2, right? This is another story that contains 3 blanks. Okay, and in Mad Libs 3, this is another story, right? This is a single line, by the way. It doesn't look like it, but it just overflowed. So this is a single line with 3 blanks, right? One here, and then finally over here. So yeah, that's pretty much the what these text files are. They are used to generate stories. Okay. There's some stuff on widgets. You don't have to worry about this too much. I'm not expecting folks to code a widget, so I'll do this for folks in just a bit. But basically, the whole goal of this project is to create a function that returns a story. In particular, this function will contain 4 arguments. It's going to contain file name, which is the story that we're working with, and then 3 other strings that help us fill in the blanks. All right. Let me take a look. So let me run this second cell here. This is going to get some widgets ready for us. All right, don't worry too much about this. Okay, and scrolling down, I wrote a couple of testing functions so folks can kind of expect what's going to happen. So it kind of, let me comment this second one out. So this cell is meant to manually test your function. Right? It doesn't exist, by the way. Right? If I were to try to run this, it says it doesn't exist, right? Because we never made this function. But if you take a look at the comment, it's going to tell us what the output should be. Right? Like we're doing do Mad Lib. Right? This is the function invocation. You see how we're passing 4 arguments into it? Right? The first argument represents the file that we're working with. So it's right here. This is the Mad Libs 1. Right, so this means that the function right here is supposed to open this file up on the bottom and then use these next arguments to replace into these curly braces. Okay, we'll talk about replacing in the curly braces in just a bit. But yeah, the point is this whole function invocation should return an HTML string, right? And with that HTML string, when we give it to the display function, it should display this line here. All right, people see what I mean? Bingo, he said happily. Right? Happily came from this second string. Right? This second string kind of replaced this curly brace. And then this car right here replaced this other curly brace. And then this apple replaced this. Okay, so I do want to clarify that the file should remain the same. What I meant by replacing was that the function shouldn't really modify this file. It should just generate a story and then return it to the caller. So here, let me help folks get started with this, and you'll see what I mean. Okay, cool. So let me define a function called do Mad Lib. Okay, there are 4 arguments here. You could scroll up to see the specifications. Right? You could scroll up and read this over here. The first argument represents the path, and then the next are strings that we're going to use. So word 1, word 2, word 3. Okay, let me go ahead and do a doc string. The purpose is to generate a story. Generates a story. a Mad Libs story. And then there are 4 arguments here. They're all strings. The first one represents the path of the story template. And then these are just strings as well. Right? It's the word to fill in the blank. Right, the word used to fill in the blank. And then same with the other ones. Word to, and a word 3. Word 3 right here. And then there's a return. We are expecting this function to return a HTML string that contains the story. Okay, cool. Let's go ahead and put that. So returns the generated story in an HTML as an HTML object. Okay, so let's kind of work from the bottom up. For now, I'm going to do a dummy return statement, meaning I'm just going to return a testing string. I'll say testing 1, 2, 3, meaning that no matter what we tell the function, it's going to give us this string. And you know what? We are expecting this function to return an HTML object, so we should wrap this in by converting it. All right, I'm converting it to an HTML string. This way the display can display a little nicer. Let's see. You know what? Let me actually generalize this a bit. I'm going to store this string into something called story. Right, I'll say, oh, story. I'm going to hard code it to testing 1, 2, 3. And then, yeah, it's the same thing. All right, this is a placeholder. So here, let me test it real quick. Cool. I just loaded the function in, and let me test it. All right, so this single line, press play, and it looks like we got an error. Let's see. HTML is not defined. Okay, great. This is why we test frequently. So HTML is not defined because we never included it. This comes from a library. You could pull those up in your previous notebooks. It comes from the IPython module .display, and then there's an object called HTML, a class. I mean, okay, cool. So let me test it again. Press play here, and perfect. Cool. So we're testing it. Currently, this function is hard-coded to return testing 1, 2, 3, right? And then we're displaying it. Okay, great. So yeah, let's go ahead and take a next step, right? This function needs to open the file name, right? Because that contains the story. So yeah, we need to open up the file name. Okay, so let me open it up. Let's see, I'll get rid of this story for now. We need to open up the file, so in read mode. Right, this does give us a file handle. Okay, let me close it. Okay, and in between, we need to load in the story. Right, because we're planning on storing the story as a string and then kind of filling in the blanks and then returning it later. So as a first step, we do need to read the first line. Right, the first line, we can use the read line function. Right, and this does return a string. This string could be the story. Right, so let's see what's happening. Right, this means the first line is stored into this string, and we're going to return it as an HTML. So let's go ahead and test it. Let's test it real quick. Okay, so I'm going to press play right here, and there you go. Right, it says bingo. He said blank as he jumped into something. Right, let's keep testing. We're not done yet, but hopefully people see where we're headed. Okay, this next function invocation, we're testing with a different file. Right? It's testing with the file Mad Libs 2, which looks like this over here. Right, this is Mad Libs 2. So let's see what it prints. All right, press play, and here it is. Here is the display from the second function invocation. All right, people cool with this so far? All right, so we're taking step by step, right? All we need to do now is kind of fill in the blanks. Right? Currently, our function, all it does is returns the first line in the file name. Now, all we need to do is kind of modify this string. Right? We need to modify this string and place these words into that string. Right, so how are we going to do that? So people kind of see what I'm saying? Right, I'm saying that these strings need to be inserted to the story. Right? And then we'll finally get what we want. These expected. Okay, so how are we going to do that? I want to take us back to a lesson a long time ago. It was lesson number 8 on quotes and formatting. You might remember we talked about the F string, right? And we also talked about a function called dot format right over here. Right, so this is kind of a good hint right here, right? You can use this function to replace strings into the curly braces. Now, for example, you might remember over here. Let me scroll down a bit. Oh, this is a good example here. Let me reuse this example. Let me quit this here. I guess I'll make another cell. Okay, I'll make a cell here. This is lesson 8. Imagine if we had like a word 1 is equal to leap, and then word 2 is equal to chickens. I'm just hard coding some values. And then imagine if we had a story, right? A story is some template. Like I like to blank with blank. Right, this is our story. And imagine if we printed the story, right? Like print story. Right, what's it gonna print? Let's see, I'll press play. Right, see, it just says I like to curly brace with curly brace. Right, we need to find a way to insert these strings into these curly brace. So we can use the format function to do that. Right, this format function will put the arguments into the curly brace. So let's go ahead and test that. Right, so you could write another line that overwrites the story, right? You could say, hey, story is now something else, right? It's going to be equal to the same thing, but we could format it. Right? We could format it, and the number of arguments will depend on how many curly braces you have here. Since there are 2 curly braces, this format function will expect 2 arguments. Right, so I'm going to put word 1 and then word 2 here. Okay, let's go ahead and test it. So I'll press play, and yeah, people see what's happening here now. Right, basically it's saying story starts out as a template, and then in this line, right, the right side gets evaluated first. Right, so story.format, it's literally going to take this and then replace all of the curly braces with the words. So then it's going to get overwritten and updated over here. All right, so people kind of seeing how we can do the Mad Libs now. We can just use the format function. Okay, cool. So I'll let folks do that, and I'll leave this as a to-do. All right, hopefully folks can handle this. To-do, fill in the words. All right, that's a to-do. Okay. Cool. All right, let me test it again. Press play. Yeah, when you're done, these should be the correct output, right over here. It should say bingo, he said happily. Okay, finally, there is this widget down here, that's already coded for you. Right? All this widget does is calls the function for us. That's really all it does. So let me go ahead and press play on this widget. Press play. And here are 4 widgets. The first one is a drop-down menu that represents all of the files that we can work with. Let me find the right directory. Okay, yeah, so this first widget is a drop-down, right? This is already coded for you. You don't really have to understand this, but at a high level, this is saying the drop-down menu will contain all of the files that have a Mad Lib and then a TXT in it. So you could actually create your own text files if you wanted. Right? You could create your own text files as long as you follow the criteria up here. Right? So you can literally make your own as long as the name is in a certain format. Okay, so yeah, that's the first widget. This represents the argument to the function. Right? So I don't want to complicate things too much, but it's literally just representing this argument here. Right? So this widget is typing it in for us. And then these next ones, these are the words. Right? Word 1, word 2, word 3. So whatever you type into here, right? Like let's say I typed in hello, something, and then I don't know. But basically, if your function is working, then the output of this should be correct. Right? It should say he said hello as he jumped into his something and drove off with his IDK. Right? That's what it should say, but our function is currently hard-coded to return only the first line. So hopefully people can fix this. Okay, let me erase this. The cool thing about this widget is it's going to auto-update itself. Like over here, if I click on Mad Libs 2, right? The second I press Mad Libs 2, it's going to refresh the function. So check it out. I press Mad Libs 2, and boom, right? It refreshed. It called the function for us again. It just passed in empty strings for the next ones. Right? So it doesn't matter what I type into here. It's not going to update this yet. But yeah, hopefully people see what's going on, right? Hopefully the widget isn't too confusing. Right? That's why I put this manual invocation here. Right? As long as you understand this stuff here, the widget will make sense. Or the widget will work. That's what I meant. Okay, if anything, we do have to fix these labels here. These labels should represent the part of speech. So this is the part where the next 3 lines can be used. Right? So the next 3 lines in the file represents the part of speech that the user should type, meaning that the label in this first widget should say adverb, the label in this second widget should say noun, and same with this one. This should say noun. Right, so I'm going to help folks out with this. You don't have to know how to do it. All we really need to do is modify the widget description. So you can actually do that right here. I'm going to copy this over here. This is changing the label. And then in the function, right, in the function, I could go ahead and change those global widgets. So the function is now saying, hey, change the widgets to these hard-coded strings. All right, so let me test it real quick. Let me press play, and then take a look at the widget now. All right, you see how it says foo, bar, back? All right, these are just hard-coded placeholders. Right? If anything, it should say adverb, noun, and noun. So we need to generalize these strings over here. Right? Instead of saying foo, we need to grab this second line here. Right? And then here we need to grab the third line, and so on. So you can do that. Right? Like over here, we need to read some more lines. Right? This first one reads the first line, and then we'll seek to the next one. So we just have to read all of these. All right, so let's go ahead and read all of these. I'll say file handle.read line. All right, this returns a string. You might want to store it in something, a string. I'll call it like type 1. And then now we just need to read in the other ones. All right, type 2 and type 3. So now these string variables are representing these next lines. And now we just need to update these to type 1, type 2, type 3. Okay, cool. Let's go ahead and test this. So I'll press play, and now we should see the widgets being manually changed. Where's my widget? Hold up. I think my notebook is glitching. Let me refresh my browser. Oh, hold on. Let me save this first. So save. You refresh. Okay. Cool. Okay, cool. Let me rerun this widget now. So, boom, there it is. Right, you see how the widget descriptions are being changed? And whenever we change the file, right, this is going to invoke the function again. So, boom, and there it is, right? It re-invokes the function and updates these descriptions. Mad Libs 3, right, are these, right? Just to verify it a bit. Yeah, see, it looks good, right? Mad Libs 3 are noun, superlative, and verb. Okay, hopefully people can do this project now, right? If anything, you just have to put in one more line. Feel free to get as creative as you want. If you want an extra challenge, you can render the selected words in bold text, or you can create your own Mad Libs files as well. Okay, cool. I hope that makes sense, everybody. Any questions? Okay. Okay, cool. Once again, don't worry too much about the widget, as long as you're comfortable with manually invoking the function. I mean, all the widget does is call the function for us. Okay, that's about it for today, everybody. Let's see where we're at. We're at week 9. Let's see what we're going to do next week. Next week might be if statements. Let me check. Okay, cool. So we're done talking about file input and output, right? The theme of this topic is that we're having data live in a different place, right? In particular, this data is living in text files. So we don't really have to hard code these text into the source code. Okay. I do want to give a warning that the next parts of class is going to feel a little crammed, I think. Let me see, because this is where the good stuff happens. On week 10, next week, we're going to talk about if statements. It's going to take us a whole week to cover this. And then we'll talk about some loops, right, ways on repeating code. Looping algorithms. This is probably the hardest week of the class. This is in like 3 more weeks. But I do want to give a heads up to folks. Basically around week 12, it might feel crammed because there's some tricky things about loop algorithms. Basically, this week is going to help us organize our thoughts a bit more. One of the biggest takeaways from a computer science class is not really about memorizing how to code things, right? Like it's not really a big takeaway to be like, oh, okay, this is how you print something. This is how you add stuff. A big takeaway from a computer science class is algorithmic thinking, which is a way of organizing your thoughts into a approach that can be represented by some sort of statements. So I'll repeat this again in the future. Right? But if you're taking a computer science class, algorithmic thinking should be the hard part of the class. Right? It's not really about memorizing where punctuation goes and stuff. Okay, let's talk about that in a few more weeks, though. Okay, thank you all for coming, and I will see you all next week. Bye-bye.